To do this, you will need to have your data sheet present. So we've got lead and we've got nitrate ions. Remember, nitrates are a spectator. So the lead half reaction, using my data sheet, I start at the top with my finger and move downwards until I find what my strongest oxidizing agent will be. So it could be lead, water, and these are my species. So I go downwards with my finger. I'm going down, 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 down with my finger, starting from the top left and moving down, and I find lead ions. So I go lead ions plus 2 electrons goes to lead. E0 for reduction is equal to negative 0.13 volts. So now I need to know the reducing agents. So I put my finger, my right hand finger, on the right hand side and move upwards for the strongest reducing agents. Now the first one that I encounter is zinc. So zinc will go to zinc 2 plus 2 electrons. E0 for oxidation is equal to positive 0.76 volts. Adding these two together, lead 2 plus zinc goes to lead plus zinc 2 plus. The E0 for the cell is going to be equal, using your calculator, 0.76, add negative 0.13, positive 0.63 volts. So this reaction is likely to happen, and you would have noticed with your fingers the left finger was above the right finger, so the power of the fingers works again. Now let's see what will happen with copper. So once again, I've got my lead ions. I've got my left hand finger on the lead ions, goes to lead, and using my right hand finger, I go all the way up until I find copper, and the copper goes to copper 2 plus 2 electrons. Its E0 for oxidation is equal to negative 0.34 volts. The E0 for reduction for the lead ions is equal to negative 0.13 volts, and you'll notice negative and negative. This E0 for the cell is going to be equal to negative 0.47 volts. So a negative number means this one here is a no reaction. Now that means, if you notice where your fingers are, the right finger was above the left finger, hence a negative number. So it doesn't work. Let's try the final example. So we've got lead ions plus 2 electrons goes to lead. E0 for reduction is equal to negative 0.13 volts. Using your finger, start at the bottom and move upwards on the right hand side until you encounter iron, and we find that iron goes to iron 2 plus 2 electrons. E0 for oxidation is equal to positive 0.44 volts. So you'll notice your left finger is above your right finger, so this reaction is going to proceed. So Fe plus Pb2 plus goes to Pb plus Fe2 plus, and the E0 for the cell is equal to positive 0.31 volts. So with the second example, it says with an aqueous solution of iron 2 chloride, oxidize magnesium metal. So I'm just going to write the ionic. I'm not going to do molecular. What's the point? We don't do molecular equations. So what species do I have present? I have iron 2 ions, I have chloride ions, I have magnesium metal, and I've of course got water. So, putting my finger at the top on the left-hand side and going downwards. I'm going downwards, downwards. Oh, there's chlorine, but it's Cl2, not Cl negative. Keep going. And I keep going downwards. And I found Fe3+, but no, it is not Fe2+. So I keep going. Down, 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 down. Oh, I finally found Fe2+. So Fe2+ plus 2 electrons goes to Fe. E0 for reduction is equal to positive 0.44 volts. Now, with my right hand finger, I put it at the bottom on the right hand side and start heading upwards. And oh, the first thing I encounter is magnesium solid. So I go magnesium solid goes to magnesium 2+ plus 2 electrons. The E0 for oxidation is positive 2.36 volts. So, looking at the positioning of my fingers, my left finger is above my right finger, so this reaction is going to occur, and it can be confirmed because when you add the numbers together, the E0 for the cell is equal to positive 1.92 volts. So the overall reaction is magnesium plus Fe2+ goes to Fe solid plus magnesium 2+. So this metal displacement reaction will happen. Don't forget to put your state symbols in. Let's try. That's just balancing. Let's try a halogen displacement. Chlorine will oxidize bromide ions and iodide ions, but not fluoride ions. So you have chlorine present in the first one with bromide ions. Now it must have been with something like sodium ions as well. And you've got water. So it came with sodium ions because you can't have bromide ions without a positive ion. So put your finger at the top and find the strongest oxidizing agent. And as I go down, I see that's chlorine. So chlorine plus 2 electrons goes to 2 chloride ions. E0 for reduction is positive 1.36 volts. Now when I've got the bromide ions, I start with my finger on the right hand side and move upwards, and I find that bromide ions, 2 bromide ions goes to bromine plus 2 electrons. E0 for oxidation is negative 1.08 volts. So this reaction is likely to occur because 1.36 add negative 1.08 is positive 0.28 volts. So notice the position of your fingers, left above the right hand side. Now let's try it with iodine. Iodide ions. So once again, your chlorine plus 2 electrons goes to 2 chloride ions. E0 for reduction is equal to positive 1.36 volts. Put your finger on the right hand side and follow upwards until you find iodide ions, and you'll find 2 iodide ions goes to iodine plus 2 electrons. E0 for oxidation is equal to positive 0.54 volts. So this reaction will occur because, sorry, not positive 0.54 volts, it's negative 0.54 volts. Remember, you have to reverse it when you are reversing the direction of the equation. 1.36 add negative 0.54 is coming out to positive 0.82 volts. So this reaction will happen. So chlorine plus 2 iodide ions will go to 2 chloride ions plus iodine. Now the last one, but won't work with fluoride ions. We know that chlorine plus 2 electrons goes to 2 chloride ions. E0 for reduction is equal to positive 1.36 volts. Okay, now you've got your finger on the left hand side. Start at the bottom of the right and go all the way up until you find fluoride ions, and you'll find 2 fluoride ions goes to fluorine plus 2 electrons. E0 for oxidation equals negative 2.89 volts. You'll notice your right finger is above your left finger. This is a non-spontaneous reaction, so it is no reaction because the E0 of the cell will come out to a negative number. So add the two numbers, 1.36, add negative 2.89, and it comes out to 1.36, add negative and you'll notice it comes out to negative 1.53 volts, and you would have noticed your right hand finger was above your left hand finger, so it is finished.